welcome everybody to week 3, day 3. SDF2 is due today. We'll talk a little bit about it. I'm not going to go over the solution because I have a feeling a lot of people are going to be last chancing this one. But if you want the extra credit, make sure that you submit a text message to me saying that you did inheritance. I'll even let you guys submit that through like tomorrow or something. You have plenty of time to get the extra credit if you did it. All right. So here we got a beach in Thailand, it looks like. Very nice, very nice. So what we're going to be talking about today is we're going to be continuing our discussion of proper class design. And we're going to be coming to kind of a lower level. Like we start off like, like make a constructor, make getters and setters, member variables go private, and then whatever other functions you need. Then we dropped it down to smart pointers. Now we're going to drop it down another level. We're going to talk about the way things used to be in the 80s and 90s for the people that make like the vector class and things like that. And we're going to be talking about those rules as well. Okay, it's still grading. Wow, you guys did not do well on this. All right, so maybe we'll talk about a alternate grading option, which I've already put up if you've checked on Canvas. About 1 out of 6 people did it. Got 11 out of 11. So, yeah, really not good. It's like an 80% failure rate on this one. So let's talk about SDF a little bit. I'm not going to give you guys the answers. But whenever the thing that I caught the most mistake-wise from you guys was you're trying to do everything at once and then compile it all at once, and it didn't compile, so you just kept changing things. You can't do that. You have to get like the I should just go into the directory Bob's BigBoy, and when you try building it at first, like it won't build. And the reason for that is because the circle class wasn't done, right? And so if you want it to build, you need to make it build. Okay, so you have to, you see how I deleted like the circle stuff here? You always want, whenever you do development, you always want your code to be compiling. You never want to be in a place where your code doesn't compile and you're doing development work, and it doesn't compile and you're doing development work. That is the absolute worst development approach ever, other than just like not doing anything, right? So the code here, the starter code, if you remember, had like, option 3. It was something like circle C, please enter the X, Y, R, for a circle or whatever. And then we're going to push back C as a circle like that. And this does not compile. This is the line that was not compiling. Okay. So what I did in order to work on the project, because I didn't want to get to circle just yet, is like I just, deleted it or commented it out, and I'll get to it later. Like you can't bite off like too much. You have to work on like 4 or 5 lines at a time. That's all the human brain is really capable of. Like we can't write all this stuff, especially when you guys are at a point where like constructors are new, and some of you try doing inheritance right off the bat without even any of the other stuff working, and that just made everything worse. So yeah, if you just comment out the circle, then your code compiles, right? The autograder does grab the entire folder. And so like you get it working, and then you pick something you want to work on, right? So like maybe I want to do, this is an easy pickup right here, right? Vet columns and rows to make sure it makes sense, or die. Do we have a die function? Yes, we do. Okay, cool. So yeah, just make an easy pick, right? If columns is less than 0, maybe even equal to 0. A 0 by 0 map doesn't make sense. It's less than or equal to 0, or rows is less than or equal to 0, or columns. I guess we don't have the max one. That's fine. Die. Okay. Typing and talking. Gotta watch out for that, Kearney. All right. So if columns is less than or equal to 0, or rows are less than or equal to 0, die. All right. And then you know what I do? I build it. I don't keep going. I test it, right? Enter the number of columns, 10 by 10. We're good. -9 by 10. We're bad. 9 by -10. We're bad. 0 by 0. We're bad. All right, cool. This is literally how I do development. I've talked about this before. New programmers are highly optimistic in their skills without basis. Like they really, like experienced programmers are extremely pessimistic in their ability to write code, right? Like I am pretty confident that this code would work even before I compiled it. I still tested it. And I tested all the different combinations, 2 positive, 1 positive, 1 negative, 1 negative, 1 positive, and 2 negative. And then zeros also, because the 0 is the edge condition, right? Like what separates experienced programmers from new ones is that new programmers think that they can write 100 lines of code at a time, and the old ones are like, no, we can't. We're too dumb. So trust the process. Yeah, you need that. Like, I think this was a good learning experience for a lot of you guys in just showing you that if you try doing the entire project all at once, like it just explodes on you. Okay. And I'm not pushing the deadline on this. I told you I'm not going to push the deadline on it. I mean, I guess I pushed it at 2:30 because I was sick and missed the 12 o'clock class. I had to call in sick because I've been fairly miserable today. But you need to, this is just the approach you have to take, right? And so maybe the next thing I would do is something like rectangle, right? And then maybe I'd work on the rectangle distance function, because that's the one thing in rectangle that actually needs to be done. All the rest of it's done for you. So, and I told you guys this was the hardest part, and just a lot of you, the math just didn't shake out on it. And what you need to do is actually just get one of these things called a piece of paper, right? You can see here I've worked out all the math, right? And so, all right, you can see I did all the math here, and you sketch out where's the center point of a rectangle, half width, half height, sample point. There's 4 different, like you have to just sit there and just like sketch it out and work through the logic. Like there's no substitute for that, and I helped a lot of people with the math on that, but it's really, you can't just like look at it and be like, all right, I'm just going to try point x minus loc x minus size x and hope that you get something that is algebraically correct, right? All of this stuff was just addition and subtraction, and then one Pythagorean theorem mixed in there as well. Almost all of it is just addition and subtraction, but you have to see, all right, and put in points, like on my piece of paper here, you can see I put in 20/20 here and 30/30 there on that corner and 35/41, and I just sit there and I just work through all the different possibilities. And I'm not a math person. If I wanted to be a math person, I wouldn't have, taken the life path that I did, but I just need to know the math to solve the problems that I solve. That's where all my math learning has come from, is like when I've needed to actually know something, right? And so like I've been getting into computational geometry, and so I've been purchasing books on the subject, and sometimes there's math, and so I have to learn the math to solve the thing. What's going on, Mr. Bill? So a piece of paper, or you can use a tablet, or you can use sketch pads, and there's graphing paper online and things like that. But you need to actually just get into the habit of like working it out. But my advice is to have done distance 2 on rectangle last, because you can get the rest of the project done. And this is something that I try to hammer into you guys. None of you should have gotten a 0 on this assignment. And yet when I'm looking at the grades here, half of everybody got a 0. A lot of you, your code didn't even compile, right? And that's not good, right? You should always make sure your code compiles. And if your code's not compiling right off the bat, well, you have to be able to understand the error messages. And if you don't understand the error messages, then you ask me or TA, like, what does this error message mean? And you always, this is something I'm going to repeat several times. You have to make sure your code is always compiling. Never do development with your code not compiling. And what I gave you this time was code that didn't compile, because I wanted you to figure that out. And it looks like a lot of you just didn't. You're just used to your starter code, and you just have to like fill in the gaps. So it was definitely a hard assignment. The the alternate way of earning these points is going to be quite easy by comparison. So those of you that have gotten this done, you're going to get extra credit. So cool. All right. Assuming you do the other one too, or you can just skip the other one. It's fine. So this one I would do last. And this is a big part of programming, is figuring out when you should do things, like what order you should do things, right? I would probably start off, these are like really easy picks, right? That's a point right there. You know, enter the X and Y for an asteroid. Make sure that it is within bounds, all right? So there's a standard pattern, by the way, for bounds checking, right? If you've got a minimum and a maximum and you got a point, and you want to know if that point is within bounds. Let me show you the pattern you should get into. So if the asteroid's X is less than 0, or the asteroid's Y is less than 0, or the asteroid's X is greater than or equal to the number of columns, or the asteroid's Y is greater than or equal to the number of rows, die. This is a very, very, very common pattern that you will see in code. And of course, it's with a signed integer. If you have an unsigned integer, you don't need these. That's why unsigned integer exists, by the way. Unsigned integer exists so that you don't have to do pointless comparisons with 0. If you have a value less than 0, guess what? It underflows up to a giant number, and that giant number is bigger than calls, and so it fails. And so that's literally the reason why unsigned int exists. It's not there so you can just have only positive numbers. You should not ever use it for that reason. Unsigned integers are extremely dangerous, because if you subtract 2 of them, 5 minus 3 is 2. 3 minus 5 is 4 billion. Anytime you do subtraction with unsigned integers, you should be like, yeah, very, very cautious. And I know like Samantha had issues with that on a previous assignment. So I even pointed out that it wouldn't compile without a circle class. Yeah, I mean, you know, I'm not trying to cause you guys to fail. I'm trying to give you guys a somewhat realistic assignment that you have to pick at the problem and solve it. Like, computer science is problem solving, and you have to start it early. I'll hammer that point too. Like, I had a person message me at 11:30 saying he's ready to get going on the assignment, and it's like, you're probably not going to get it done in 3 hours. Like, yeah, I'm not targeting you, Lewis. Yeah, you hopefully didn't start at 11:30. Okay. So this pattern though, bounds checking. Okay. And then for the rectangle, there's a very similar thing, right? Except you have to figure out what the minimum X is, the maximum X, the minimum Y, the maximum Y. That code actually already exists in rectangle.h. I'm not going to give you the answer here. Another skill you need is to be able to look at existing code and be like, oh, that's useful. I can steal that, right? Center point minus the half width, that's the minimum X. Okay. Center point minus Y, it's the minimum Y, you know, and so there's a lot of code in like point.h that you wouldn't even necessarily need. Like, I deleted a lot of it, it looks like, but like for the double right arrow and the double left arrow operator, like this is very, very close to what you needed for like the circle double right arrow. Like, I always try to give you things that are like close, and then you have to copy and paste it, but use your intelligence. Like, you can't just copy and paste blindly. You have to use your intelligence. You're like, okay, well, if this is a point, and a point has 2 variables in it, and a circle has 3, you know, what do I need to do differently, right? So you have to open up circle.h and do this. And a circle is going to be a float X, Y, and R, right? And so what do we got in here? So we look at this, point. We should probably change point to be a circle. All right. And then over here, we have an X, we have a Y. The point had X and Y. Circle has X, Y, and R. X, Y, X, Y, R, X, Y, X, Y, R. You have to learn how to copy and paste and plagiarize intelligently. Okay, this is a key mental skill in computer science, is learning how to plagiarize intelligently. Bad programmers will just copy and paste code off Stack Overflow and it doesn't work, and they have no idea why it doesn't work. I copied it, it doesn't work. you have to be like, okay, but the thing I copied from has an X and a Y. The thing I'm making has an X, a Y, and an R. So I need to add the R in here, and add that, right? That's the computer science brain, right? Is intelligent plagiarism. Yep. Theft, but smart. Yeah. Every programmer copies off Stack Overflow. It's like the repository of shared knowledge. But if you just blindly copy, you don't know what any of it does, your code's not going to work. You have to be able to look at it and be like, okay, that's close to what I need, but I'm going to change it now to be exactly what I need. And that's why you have to go to college and take classes and have these skills repeatedly hammered into you through failure, learning through failure, right? So, so on this assignment, I would probably do the bounds checking first. Then I'd get circle going, and then the last thing I would do is rectangle. Then I'd do rectangle. Then the last thing I do is probably refactor it to be a vector of unique pointers of shapes using inheritance. Okay, that's the order I would have done it in. Bounds checking first, circle second, rectangle third, inheritance fourth. Okay. All right. So enough on that. I assume a lot of you guys are going to be using your last chance on it because I've seen the grades. So I'm not going to give you the answer on it just yet. All right. Trial and error is not a great way of doing coding. You should understand what you're doing. You should understand what's happening there. So today we're going to be talking about making a vector class. Okay, this is an important milestone in every computer science student's life when you're going to make your own vector class. Okay, so class vector. So what is a vector, right? It's a growable array, but what is it underneath the hood? Do you know? Thank you. I don't have any. Hang on, let me pause the stream for a second. And thank you for the well wishes. I appreciate them. I'm not dying as far as I can tell. But I didn't want to come to school today because I don't like getting other people sick. And I like you guys. So there you go. All right. Gotta clean your inner spam. So what is a vector? It's kind of two things. It's a pointer to the beginning the data is. So if is that a shoe cup? It looks like Das Boot. Ben Court posts this thing all the time for some reason. I'm not sure why, but he loves it. So vector pointer. That is not what I was looking for. There you go. So this is, I don't feel like drawing it right now. Okay, so, so you can get a nice picture. There you go. All right. So vector is like an array, okay, but it's a growable array. And so what we have to do is we have to have an array, and that's the pointer. A pointer is an array, and array is a pointer. And it's going to hold our storage area. But here's the thing. When it gets full, when we fill up our array, we have to make a new array. And we're going to have to copy over all of the stuff from the old array to the new array. So we're going to need to keep track of a couple things. One is elements, maybe. And one is size. Okay, this is the size of our array. And this is how full our array is. Okay, and these are all private, right? The implementation details of a vector should not be exposed to main, right? So what should we do next? Public section, right? Vectors are effectively infinite, but they're not. They're actually finite. They're actually size 100. And then when they fill up, it secretly underneath the hood allocates more RAM, copies the old elements over, and then you know, if that fills up, you make a new one that's bigger and you copy those elements over. You typically double the size every time, but it doesn't have to be doubling. But we typically like double the size every time so that you don't have to do copies that often. You can pretend that they're infinite. You could do realloc, but there's no guarantee that that helps really. Okay. So, if you think about it technically without noticing, it's funny. Okay, whatever. All right. So, what do we do? What's our next step? Vector pointer gun. Oh yeah. Isn't that from like isn't the null pointer like Borderlands 3 gun? The null pointer. Yeah. So, step one, we're making an ADT. Step one, we've made private member variables. What's step two? Getters and setters are not next. That's step three. What's step two? Initializers, yes. Constructors, yes. All right, so we will make a constructor named vector. This function will get called if we make a vector like this, named vector, named Victor. This calls the default constructor, and this boy here is the default constructor. What does the default constructor do? Absolutely nothing. But it will actually invoke these things here. We should probably set u equal to null pointer as well. We actually don't need to repeat ourselves when you have initializers here. The default constructor actually calls these things under the hood. But what other types of constructors do we care about? What's the big one? What if we did vector vec of size 100? What do you think? Are you guys with me on this? This makes a vector of size 100. It makes 100 integers. Right? We're making a vector of integers, by the way. All we hold are integers. We'll get into holding other stuff in a future episode. Yeah, Betancourt, I know that you know it. We've got 41 people on the stream right now, and only Voss is saying he understands it. So, what kind of... Okay, vector... Okay, so what we're going to do here, this is not the default constructor anymore. This is now the one parameter. And what we need to do is make a vector of size. Okay? So we will say pointer equals new int of size, like that. And size, this points to size equals size. And there you go. So that will allocate room for 100 integers. And do you do evil with magnitude and direction? Yeah. So do you guys see what we did here? So we're writing down, we have 100 integers right now. They're all uninitialized. We can initialize them if we want by doing this. One to two. So we wouldn't use smart pointers in this case. We're talking about how, like I said, we're going down a level from smart pointers. So the first time we talked about proper class design, we did it at a high level, like you're going to have a vector, you know, just in your class or something. Then we talked about smart pointers. Now we're going down to raw pointers and how, like these, like how is smart pointer made? How is vector made? Yep. It's everyone's rite of passage to make their own vector class, and I'm gonna get it going for you guys, but then you're gonna have some lab time in a bit. Okay. So if you pass in 100 like this, it's gonna allocate room for 100 integers, save the result into the pointer here, and it's gonna write down we have capacity of 100. Okay. Maybe we can call it capacity. Maybe that's a better thing than size. And then size is usually how many elements you have. So we'll do this instead. How many elements? I oftentimes don't know how I'm going to name something until after I start using it. Our vector has, and capacity is max elements we can store. Okay, so it's going to be, this points to capacity. Okay. And size is still 0 because we still haven't put any elements in it. Okay. So we need a delete. Yes, we're gonna come to that in a second. Feasibly, we could do another constructor like this one. Like we can make 142s. Size, integer value. This will be our 2-parameter constructor. So we're going to do the same thing. We're in a new room for 100 integers. We're going to write down, we have a capacity of 100, and then we are going to fill it, really. I think size is going to be equal to this as well. This points to size. So size and capacity are it's going to be at capacity, right? We're going to make 100 things and they're at capacity. And then we have to fill the array. Okay. Mimset. What's this? C? How do we fill an array with 42s or whatever? What do we do here? A for loop? Yeah, for loop works. There are standard library functions to do this, but you know, a good old-fashioned for loop works just fine. Integer I equals 0. I is less than size. I plus plus. Pointer, square bracket. Should we call it pointer? No, I don't like the name anymore. You are now R. Everybody say R. Like I said, I don't know what I should name things until after I use them. R, yar. Avast. Isn't that like a antivirus, Avast or something? All right, so array I equals value. Okay, we will fill the array with 42s. You guys understand what's happening here? What's the matter with this? Oh, we've already got that vec. So you're going to be vector 2. There you go. Bencourt, you don't have to say yes. You're gonna make the 41 students feel bad. They don't understand. Yes, ended with no. So that's a no then, Aaron. Okay, you don't understand. What do you not understand? So this is going to call the default constructor, right? Because I provided no parameters here. If I wanted to, I could have written it like this, I guess. I don't really do that, right? Nobody does that. So this calls the default constructor. This calls the 1-parameter constructor. This calls the 2-parameter constructor, right? 1-parameter constructor takes the size. 2-parameter constructor takes the size and the value we're going to initialize it to. So this is saying make 100 integers and set them all equal to 42. So it comes up to here, size is 100, value is 42. So it makes a new array of size 100. It sets the capacity and size to be size. So what's the most number of elements we can store? 100. How many are we storing? 100. We're at capacity. No more room at the end. Sorry, Mother Mary, no room. You got to go to the Motel 6. All right, so what is this? This is a for loop starting at 0, going to the end of the array, putting every element in the array equal to 42. Okay. What is interesting? Size underscore t and int value. Size t is what you use when you index into arrays and vectors and things like that. On our system, size t is equivalent to unsigned long. It's an unsigned 64-bit number. But on a different system, size t could be different. If you're on a 32-bit system, it's probably an unsigned int or an unsigned long. What is a null pointer? 0, effectively. So it is a pointer that is pointing at nothing. You get nothing. You lose, sir. So when you initialize a pointer, if it's not pointing anything, you better damn well make sure it is pointing at null pointer. All right. And if you've ever heard of a null pointer exception or an NPE or the gun from Borderlands, that's funny. Any pictures of null pointers? It points to nothing. So it literally points at memory address 0. And if you guys remember what we talked about last time, if you ever read or write to 0, that's called the 0 page, and it kills your program. The 0 page is marked as non-readable and non-writable. So you understand what it is now from that image? Cool. So if we have an integer pointer here named Putter, thank you, Art Dwyer, and we initialize it to 0, which is the same thing as initializing it to null, which is the same thing as initializing it to null pointer. All three of these things are functionally the same. This is the lazy and bad way. This is C world, and this is C++ blessed way. Okay. All three of them are essentially doing the same thing. They're creating a pointer. What memory address does it hold? The memory address 0. And so if you're not pointing at something, you should damn well make sure your pointer is pointing at 0. That means it's not pointing at anything. And it's widely regarded as a bad design mistake, but there you go. The nice thing about 0 is that 0 is false. Right? So you can check, you could say if pointer, good day, sir. Say if pointer, see out, star pointer. And this won't crash, right? Whereas if you do this, see out, star pointer 2, this code's gonna encounter difficulties, right? There you go. All right. So do you guys understand that this code here is going to crash? All right, because we're reading from the 0 page, right? The minefield of doom, I call it. Star pointer equals null. No, that sets the pointer equal to 0. It's not reading or writing through it. This is actually accessing the 0 page. This is initializing the pointer to be 0. So it's putting a 0 into the pointer. It's not actually dereferencing the pointer. This star here and this star here means something completely different. Hey, they do not mean the same thing at all. The ampersand operator and the star operator apply to variables, and they return either a pointer to the variable or they dereference a pointer. When it's in a type, this means that this variable is an int star. You can think of it, and it'll compile the same way like this. What type of variable is this? It is an int pointer. What does it hold? Addresses of integers. And if it's not pointing at anything, you make sure it points at null to mean that it's not pointing at something. So it does not die until actually used. You can use it. Like I could say like pointer, I could say like pointer 2 equals pointer 1. That's fine. I'm not dereferencing it. That star there is the dereference operator that says load from whatever is at memory address 0 and tell me what's there. That's what causes the kill. Because anytime you load from the 0 page, anytime you write to the 0 page, the operating system's like, "Nah, you done goofed," and kills you, right? So if you tried setting, the value there, like star pointer 3, the value at memory address 0 is set to 100, that's going to kill your program. Dead. Instant. Believe it or not, dead. Straight to jail. Dead. Okay. Right there. This is the dereference operator. It's trying to say, go to memory address 0 and write the value 100 into RAM there. And you can't. The 0 page is marked as non-readable and non-writable. So, right away, straight to jail. You overcook your fish, you undercook your fish, right away, straight to jail. All right, so you can put values into the pointer. It's when you dereference the pointer. That's called dereferencing a null pointer, and it is a classic mistake. There's a wrestler named Bret Hart. Have you guys ever heard of him? Wizard surrenders the OGL. Ooh, victory! Look at that. 50 minutes ago. That's hot. All right. Bret Hart. What was I? All right. So Bret Hart is the greatest that is, that was, and ever will be in pro wrestling. And most people don't know this, but he's actually a professional, or was, he died. He was actually a professional programmer, right? So you can see him working on the old Nintendo wrestling games back in the day in his full body spandex outfit. And so...
Come on, guys. There it is, right there in front of you the whole time. You're dereferencing a null pointer. Open your eyes.
So, yeah, when I program, I'm usually in my pro wrestling tights as well, but I dress up in a polo t-shirt for you guys, so I look nice. So, yeah, you just went, you're dereferencing a null pointer. So, that code there is fine, because it's just copying. Because an integer, I mean, a pointer under the hood is just an integer, really, or in this case, an unsigned long. It's just copying the value of like 0 into it. That's fine. But when you dereference it, it's trying to load from RAM there. Dead. Instant death. Okay. So, you can protect yourself by writing code like this. You can say, if the pointer is not null, then print out the value at the pointer. This is called a check for a null pointer. And you're going to be doing a lot of these. A lot of these this semester. Okay. Another way you could write it, if pointer is not equal to null pointer, that's another way you can write it. It's the same thing. Remember, 0 in C++ is false. So if it is 0, it's false. It does not execute the if statement. If it's anything else, it's true. So if it's at a legitimate memory address, pointer is true. And then it will print the value held at that legitimate memory address. So that's a very common construction. If you want to be more clear what you're doing here, you'd say if the pointer is not null. But that's literally the same thing as saying that. So pointer is false when null and true when not null. Yeah, because null is 0, right? That's why I showed this to you. You don't want to write code like that, because you can always screw it up. You know, like, what if you did this? You know, like that's a... What if you added 0, like, to a number, and like, you don't want to... It's not good. So this is the blessed way. You're supposed to write equals null pointer. That's the right thing. Null is actually just 0 with more letters in it. So next company's exam, we're going to test if you can bench 200 pounds. Yeah. Okay. So 150's, nah. We're going to go for 200. All right. So, yeah, all right. so there's some pointers. Just leave this one up here just so you can admire the correct way of doing it. So what we're doing is we are newing memory. Probably, we should check to see if the new fails, it returns null pointer. But nowadays, like, you rarely run on a RAM. Like, it's almost not even an issue. Back in my day, my computer had 16 megabytes of RAM when I was in college. Maybe 32 megs of RAM, something like that, when I started college. And you could run out of RAM real fast. Like, real fast. So, every time we did a new, we would, like, check to see if a null pointer came out. And if it did, we'd print out of memory and die. Nowadays, unless you're doing something really egregious, you just don't run out of RAM. And so it's not a huge deal. What if you bench press Stallman? I don't know. He's I don't know. He's unpressable, I think. All right, so neat. All right, what's the next thing we need to do here? We've got our constructors. We've got our private member variables. What's next? .at. Yeah, getters, setters. But here's the thing. Which one of these things should we actually care about getting and setting? What do you think? Size, yeah. The only thing we actually care about is how many elements are in the array. We actually really don't care what memory address the pointer is. Now, the actual professional vector class does actually give you the ability to grab the pointer out of it. I think you can either set the capacity or you can like hint at what the capacity should be. But I think for our purposes, we don't care. So all we need really is an integer get size, and that, yeah, sure. Should be const, right? Because we're not changing anything, and then we will just return size, and there we go. So that is a getter. We don't need getters for the array pointer. We don't need a getter for capacity. Those things really don't, like, main just should not care. The only thing you should care about is like being able to for loop over a vector, right? For every element in the vector, print it to the screen, that kind of thing. It needs to be able to get the size. Okay. Or in C++ terminology, it's just size, right? Which I'm not really a huge fan of some of the names that the standard library has picked, but whatever. All right, so we've got get size. We don't need setters, I don't think. Right? Do we want to just change the pointer we're pointing at? Do we want to change the size? No. We have an invariant, right? What invariants do we have? What promise do we make about these member variables here? It's always going to be true. There's a couple. R, okay. So R is null if empty or pointing at a valid chunk of RAM if it has stuff. If otherwise. Okay. So if we happen to delete everything in the vector, we should set it back to null. That's actually something we need to write down. Okay. Okay, what else? Class invariant. It's French now all of a sudden. Class invariant. What do we got? Size can't be less than 0. Okay. How about size holds how many elements are in the array? Always. So that's why I don't think there should be a set size, right? Like, what if you put 3 elements in and you call set size 50? Now you think that there's 50 elements in the vector? No, there's still only 3. You haven't called push back. You just tried changing size. No, that's bad. All right. So capacity should always be greater than size, yes, or greater than or equal to size. Class invariant. Number 3. Capacity should always be greater than or equal to size. Right? You don't want to write off the edge of the array. Right? Okay. Capacity is your max. And so, yeah, you can't go beyond it. And also, capacity always needs to be the size of the array. All right. So whenever we knew something, we need to write down. I don't like the word size anymore, but whatever. We need to write down how big that array is into the capacity. So, don't vectors have max size? I think I don't know if they're. Like, a lot of those things are just hints. Like, you can set things on them. Like if you do capacity returns the number of elements that can be held. Okay, so that is yeah. So you can get capacity if you care about that. But things like reserve, like does not change the size of the vector. I think it can ignore it. I could be wrong. Some of these things are just hints. Like, they just kind of are like, hey, I'm planning on using this much stuff. So sometimes they'll just ignore the things if they feel like it. But yeah, I think get capacity, sure, why not? Maybe main cares about it, I guess. I don't see why they should. No, we don't care. From main's perspective, we just want to stuff things into the vector and then be able to read them out again. Okay. So I think reserve just lets vector how much memory it can store. Yeah, I'm not sure if it's binding or not. I've heard that. I could be remembering wrong, but I think it could ignore reserve if it wants to, or maybe it can go over it, or I don't know. I don't remember the details. Okay. So what other functions do we need? So we've got our vectors here. We got vector. We got this has 0 elements in it. This one has 100 elements, all of which are 0. And this one has 100 elements in it that are all 42. So what do we do with vectors? What are our primary operations that we do with vectors? We need to be able to assign and read from the vector. We need to be able to read and write to it. So we could do the square bracket operator if you wanted. Resize, yeah. Well, resize is going to be hidden underneath pushback, right? So the two functions that I typically have you guys use is at and pushback, right? And so at is going to return the value at index. But what does at do? What is the benefit of at over square bracket? You guys remember? Why do we always recommend you use .at in this class and not .square bracket? It does bounds checking. So how can we check to see if this index, like let's say it asks me for element 200. How do I check to see if element 200 exists, or is real, or because this vector could be like partially filled up, right? So how do we check to see that it's within the zone that we've pushed back things into? If 200 is over bounds, modular. If we want to we're not doing circular arrays. Check if index is greater than size. Greater than size. Greater than size. So if we have 5 elements and ask for element 5, it's okay. Greater than or equal to, right? And you know how I showed you that bounds checking pattern, right? Let's say that we're going to use an int here, right? This bounds checking pattern comes up all the time. You check to see if they pass in an index less than 0, or if they pass in an index greater than or equal to size. I told you this pattern comes up everywhere, right? And so the reason why I didn't need checking for less than 0 before was because I passed in an unsigned integer, which eliminates this half of it. That's why people use unsigned integers. So if the index is less than 0 or an index is greater than or equal to size, we will throw, I don't know, exception. Where was it? What does it throw? It's a runtime error. Vector. Is it throw? Do not have the exceptions listed here. Dot at. Out of range error. Okay, so this is instead except. Okay. Okay, so we will throw an out of range exception saying you suck. Boom. Mic drop. All right. Okay. Otherwise, we're within bounds, right? So what do we return? So this is our array. Let's say our array has 100 elements in it, and we're asking for element 42. That's within bounds. It's perfectly fine. How do I return index 42 from array R? Pointer plus index. Good. You could return array plus index. That's a thing you could do, I guess. But you normally just use like square brackets for that, right? Yeah, R square bracket 42. Pointers are arrays. Arrays are pointers. There's fundamentally no difference between the two. What is an array? It's a pointer to the beginning of the array in memory. What's a pointer? An address in memory. How many elements does a pointer have? Who knows? 1? 100? You don't know. Nobody knows. How many elements does an array have? I don't know. Nobody knows. That's why you have to track it, right? That's why C arrays suck, because their size doesn't come with them, right? You have to, every time you work with a pointer or a C-style array, you have to track the size of it separately. And that's why like all of these C functions that take arrays, like man, strcpy, they usually take in a size separately. Whereas in C++, we use a string class, and the string class comes with its size. The vector class its size comes with it. With a C-style array, you have to write that down separately somewhere and hope that they don't get out of sync. So you've got your array of size 100, and you write down its size 100 somewhere else and hope that you don't screw that up. And every time you pass it to a function, you have to pass two things to the function. You have to pass the pointer, you have to pass the size. And it's annoying. So it sucks. That's why vectors are better. We're making a vector. All right. So there's .at. And what if we want to change it, right? Because this is just returning an integer, right? Like if I did this, cout vector2 dot at 10. Excuse me. What is this going to print to the screen? We're printing out element 10 from vector 2. Yeah, it's going to print out 42 because they're all 42. Thank you. What if I tried printing out element 100? What would that do? All right, see if I can correct. So just to verify, because I haven't tested my code at all. There you go, got a 42, awesome. So if we try printing out element 100, now we get a exception thrown, out of range error. What? What? You suck. What? You suck. It's the Lil Jon, right? Right? What? You suck. Okay. But what if we want to do this? What if we said like vector 2.at 20 equals 800? Can we do this? Why is this not good? Why is this not working? The red arrow says no, but you guys should know by now not to trust it. Why can I not do this? I'm setting a number to a number, right? It's returning the number 42. So essentially what this code says is 42 is equal to 800, right? This doesn't make any sense, right? Like, you can't change the number 42. But that's what we're doing here. We're returning the number 42 and then trying to change it to 800. But that's not how it works, right? Expressions unassignable, expressions unassignable. So how do we make it work like in the C++ vector class? What if I told you, yeah, you probably don't know. It's a mystery. What if I told you you could actually return a reference like that? And so instead of returning 42, it returns what amounts to a pointer to 42. A reference to 42. It's actually the original 42. Remember, call by reference before, we were passing the original variable from main into the thing, and now we're doing it the opposite way. We have a function call that's actually returning the original value from the array. It's essentially a pointer. You're returning a pointer to it. And then we're going to write to that memory address the value 800. And it worked. Look at that. In C++, references look like regular variables, but what they actually are is a pointer. It returns a pointer, but they act like regular variables, so it automatically dereferences it for you. So every time you have a reference, it's returning a pointer, and then it dereferences it for you, and says write to that memory address the value 800, right here. And so now you can use the .add operator to both read from it and write to it, because it's actually reading and writing to that element 20 in the. It's not returning a copy. That's actually element 20 of the vector making its debut appearance out in main, and we're setting it to 800. Your compiler is throwing errors on the size in the for loop. This guy? What's the matter with it? It is not going to see out the RAM location. Anytime you have a reference, it pretends to be a regular variable. Okay? So like if I have, I don't know, integer x equals 420, and integer y, it's a reference, equals x, this is actually a pointer to x that behaves like a regular variable. Because pointers are scary, and people don't like them. So instead of integer pointer bob equals the address of x, these two guys are effectively exactly the same thing, right? Y is a pointer to x, but when you use it, it automatically dereferences it for you. You don't have to put the star there, because the star is scary, and people are afraid of it. And they don't know what they're doing, so they just start like putting like ampersands and like stars in front of things, like, because they don't know what will make it work, you know, because they don't have a good grasp of pointers. And so that's why references exist. This reference here means it is a pointer to x, but it behaves like a regular variable. Look, it's just a regular variable. It's an integer. Look, you know, I can go y++. But what's happening under the hood is it goes to the memory location of x, increases x by 1, and then comes back like, I'm bigger now. You know, I'm a regular variable. I'm like all the other girls, right? So the this is actually a pointer that behaves like a regular integer. Okay? And so if we were to print out the value of x, and print out the value of y, and print out the value of Bob, you'll see that Bob is actually a memory address, right? The value pointed to by Bob. We got a RAM address there, right? All of them are 421. Because y is pointing at x, Bob is pointing at x, and x is x. And so when we did y++, under the hood, it went to the memory address pointed to by y, incremented it from 420 to 421, and then it's like, I'm y, look at me, I'm a regular integer. And so all three of these guys now have the value of 421, because we've aliased it 3 different ways. There's 3 different names for the same memory address now. Okay. So that is what's going on here. So references are cool. And the other neat thing about a reference is that pointers can be null. References can't really be null. although you can abuse the language. Like you can do casting tricks to cast a null pointer to be a reference or something like that. Don't worry about that for now. Basically, pointers can be null. References can't be null. References always point at something. And that's why you have to throw an out of range exception. Because there is literally no reference you could return if it's out of range, right? Like, imagine the vector is empty and you ask for element 0. It has to throw an exception. There's literally no chunk of RAM whose address you can return, right? And you can't return a null pointer because references always have to point at something valid. You can't return a null pointer if it's a reference. So that's why exceptions exist, basically. Because there are sometimes where you literally can't return a reference because there is nothing to point to. And so you have to throw as a result of it. Okay, so it's complete about a memory leak. Good, you have a memory leak. Okay, you have a memory leak. How many news do we have? How many deletes do we have? You got 2 news, you got no deletes. Yeah. So that's a problem. So, the topic for today is something called the rule of 3, which says this. If you are allocating resources, usually RAM, in a constructor, you need the following 3 things. You need a destructor. You need a copy constructor, and you need a move operator, assignment operator. Operator equals, and then maybe also a move constructor and move assignment. And that is something called the rule of 5, but we're not going to worry about that for now. We're just going to do rule 3. Okay? So, what is a destructor? A destructor is a special function that gets called when a variable goes away. So, for example, when it's got a name equal to the class with a tilde in front of it. And so, if we have our destructor here, just say, I am dying right now. When a vector goes away, when it goes out of scope, which is right here, when it goes out of scope, it's going to print to the screen, I am dying right now. Yep. And so you can see, we ran through all of main, it printed out 800, it did this, and then when main ends, it kills all 3 of the vectors, okay? Like Kai, the hitchhiker, right? This guy, who I might have played D&D with once. I'm not sure. There was a homeless guy in our D&D group called Kai, and I bought him a Jumbo Jack once, but I don't know, didn't look like him. Might have been him. I don't know. It's hard to say. It was a long time. It was like 30 years ago. So, 30 years ago. Was it really? No, 20 years ago. Okay, so it's dying right now. I'm dying of cringe. But this is not what we want. What happens when we die? Right? What should we do? We've got a new. What do we need here? We got to clean up after ourselves. You always have to have balance to the force. If your constructor is allocating memory, your destructor needs to delete memory. And there are 2 different kinds of delete in C++ because it sucks. Do we want to do the regular delete or do we want to do the array delete? Which one of these is the correct delete for our array? I have become death, destroyer of worlds. That's what I used to say back when I did finals. Right. By the way, Oppenheimer didn't actually say that. He made that whole thing up later. At the time when the bomb went off, he's going, "Wow, it worked," and then later on, he's like, "When I saw the fiery glow of the sun, I thought to myself, a quote from the bag of Vita came to mind. I have become death. Like, no, dude, you're just like, oh, that's bright. Yeah, Oppenheimer is kind of an asshole. Like if you talk to people like the Princeton Institute for Advanced Studies or whatever it's called, EIS, something like that, like they're like, meh. Like a lot of people liked him during the Manhattan Project, but like at Princeton, like they're like, he's just a terrible manager. He's always trying to talk about how smart he was and would interrupt people that are giving talks to talk about how smart he was. And my Batman voice, yeah. When you got a cold, it's always your Batman voice. Welcome to Seaside 41, kids. I'm taking cough medicine right now. Yeah. How can I make murdering people sound cool? Exactly. Kilimanjaro. All right. Yes. So this is correct. If you have a new and a ceaser, you need a delete and a deester. Okay, that's the rule. Boom. That's the single most important thing. Because otherwise, every time you make a vector, you're going to leak memory. Because you're allocating memory, you're not deallocating it. So this brings balance to the force. Now you might be like, but there's two news, right? There's two, and there's only one delete. Yeah, but can you call two constructors, or is it just like one or the other? Right? You thought Oppie regretted creating the atomic bomb? I mean, yeah. You know, people say a lot of things like later on in life. Like RFK during the Cuban Missile Crisis was like all for like attacking Russia. And then afterwards, after JFK's plan to quarantine Cuba played out, he was like, yeah, I was for peace all along. Look at how smart I am. He published his memoirs called, what was it called? 7 Days. October, 13 days, sorry. Not 7 days, 13 days. And so RFK wrote his memoir and talking about how he came up with these great ideas that saved humanity. No. As it turned out, the XCOM meetings were all recorded secretly by JFK, and when they came out, like RFK was like, yeah, we should attack. Let's nuke the Soviet Union. That'll be great. People say a lot of things in their memoirs after they know how it played out. So they printed die 3 times, so assuming it runs the times it needs to be. Well, it printed die 3 times because we got 3 vectors, right? Each one of those, when they go out of scope, it calls their destructor, right? Does that make sense, Caesar? Okay. Where is Rachel? All right. So we need to do pushback, okay? So what if we give different names for R and different constructors? You can't give it different names because it's a member variable, right? Right, you're initializing, the constructor initializes the member variable. Like if you were to make like some local variable here, like int star whatever equals new int 1000, this is going to straight up leak memory because this is not a member variable. You have to make it a member variable like this. And the class is going to track that location in memory. You've allocated 100 ints. It's going to track it all along, and then when it goes out of scope, it deallocates it, and you have not leaked memory at all. This this concept, this philosophy, the C++ philosophy is this. Allocate resources in constructors, deallocate in destructors. And this is called resource acquisition is initialization, which is one of the dumbest acronyms ever. But you'll hear people talk about RAII or RAI. It just doesn't make any sense to me. Resource acquisition is initialization. It's more like during initialization, you should acquire your resources. It's like backwards, but okay, whatever. You'll hear it called RAI, right? So that's the C++ philosophy. Basically, when you knew something, you should only knew something in a constructor, and you should only delete things in destructors, and then you won't leak memory. And you won't have a double delete because you're allocating memory here, and then it automatically deallocates when it goes away, And guess what? That's how a smart pointer works. So a smart pointer works by allocating memory in its constructor, and then when the smart pointer goes out of scope, it deallocates the memory, and everything's magically balanced, as all things should be. So there is two other things, though, that we need to talk about, the copy constructor and the operator equals. And then I'm going to give you guys lab time to work on pushback. Pushback is the heart of vectors. Okay? And then we'll come back and talk about your alternative way of fulfilling the SDF2 requirements. Okay, so a copy constructor gets called when a destructor gets called when the variable goes away. The copy constructor gets called when we clone the variable. So for example, if you pass a variable call by value, it clones it. Or if you initialize one vector with another vector, it clones it. So it's called in two places, in a vector Bob equals Steve, or call by value. So if you have a call by value function, it calls the copy constructor. Or if you just like copy one thing into a new thing, that's a copy constructor. The operator equals is very similar to the copy constructor, except it's called when Bob equals Steve, but Bob is not a new variable. It's very close. The equals operator and the copy constructor operator are different, but they do basically the same thing. And most of the time, your code for them is going to be the same. It's just the copy constructor is called when you're making a new variable named Bob of type vector, and the equals operator gets called when you're just saying Bob equals Steve. Bob already exists, Steve already exists, and we're going to copy from one to the other. And that makes a difference because if Bob already has an array, it needs to release it. With this, you know that Bob doesn't have an array already because he's brand new, right? But for the equals operator, it's quite possible Bob is already pointing at a megabyte of memory, and so you need to deallocate that first, then copy Steve over. Okay, so all right, so a rule of 3 right here goes over all this stuff. I posted the link on your next homework assignment. We can read about it. You're going to have to do the rule of 3 for your homework assignment. That's going to be due on Wednesday. It will be worth 10 points. If you have done SDF2, you don't have to do it. If you do it, you'll get extra credit. If you have not done SDF2 or done part of it, the points on the upcoming homework assignment on rule of 3, 5, and 0 is going to add to your SDF2 score. So this is the rule. If your class requires a destructor, a copy constructor, or the copy assignment, which is the equals operator, then it almost certainly needs all 3. Anytime you need one of them, you need all 3 of them. And I'll show you why in a second. So here you've got a pointer, and the constructor is going to probably new something. Where's the new? Mim copy. Oh, there's the new. Okay. So the constructor is going to new something, and then the destructor is going to delete it. Yeah. But because of this, you're going to need a copy constructor, and you're going to need an equals operator. I'll show you one. So by default, C++ will make a copy constructor and a equals operator for you, right? So if I have struct point flute xy, if I point Bob is equal to 420, 690, and I say point Steve is equal to Bob, and I see out steve.x and steve.y, what value is it going to print? Yeah, we're not going to do rule 5 though. It's enough as it is. And you can oftentimes just delete the move operator. Well, I mean, not if you're doing a vector, I guess, but Well, we're not going to worry about rule of 5 today. All right. Yeah. So what happens here is that this calls a default copy constructor. Okay. So what's happening here is that C++ actually makes one for you. And in cases like this, it's usually pretty good. It just copies all of the, it just says steve.x equals bob.x, steve.y equals bob.y, done. If you wanted to, you could like delete it, and now this code won't compile because we have deleted the copy constructor. So if you delete the copy constructor, you're saying you cannot copy this value. And I actually do this a lot. Like if I'm making something that should never have a duplicate of it made, I will very often delete the copy constructor. So this is actually a thing I do a lot. But let's actually write it out. Okay. So we're going to say my x is equal to points x, and my y equals to the other guy's y. And this one is for an initializer list. Once you make one constructor, you kind of have to make all of them. Point float new x equals 0, float new y equals 0, x equals new x, y equals new y. There we go. Okay. So this is going to call this function here. You can use initializer list too if you want. Cout, I am a copy constructor. I just got called. So when you say Steve equals Bob, it's calling the copy constructor. Okay. This is doing exactly the same thing that the default one does, right? So when would you not want that? Like what if you wanted to do something really horrible and mischievous? And like every time you copy a point, the x and the y values change. Should you write code this way? Is this a good idea? You know, you copy a point from one point to another point and the x and the y values switch. Well, why not? People are going to be very upset at you when, you know, you get the values backwards, right? But you're right, Caesar. It is job security. That's exactly right. So nobody can fire you now because it looks like you're just copying the variable, but you're actually swapping it. So, do the reverse ray. So, job security. Yeah. Yeah. So don't do this. So when would we need to write our own copy constructor, right? Like, are you guys with me on this? Like, it seems like there's no point. Like the default one's pretty good, right? Like the default one seems to just kind of do what we want, right? So why would I ever want to write a copy constructor? It's not a rhetorical question. Do you guys know? No clue. Yeah, because like if I were to just come in here and just like delete this whole thing, like it would just work correctly. Yeah, because the default's pretty good. If you want to change values without changing other values, yeah, you could. Usually that's not a thing, because when you're cloning something, you want it to be totally the same. Now, this actually, like I said earlier, like it's actually fairly common for me to do this. If I have a value that shouldn't get copied by accident, I will delete the copy constructor so that I don't accidentally clone everything, which is sometimes what I want. If there's an object that there should only be one of. Like if there's one player in the game, and you accidentally clone the player, you're going to be making changes to the clone, and the clone will go away, and the original player won't have the changes made, and you're going to be like, what the hell's going on? So if you're in a single player game, you can make the copy constructor for the player delete, and then that will not allow it to be duplicated. You can only pass it by reference. You cannot pass it by value, which is good a lot of times. Okay, when you can't use the default one. Yeah, well, okay. Let's justify this. So let's come up here and show you something. So if I were to, you know, I'm going to give you a get. I'm going to make all this public. Why not? I'm just going to show you something. Okay. So we've got vector Victor, we got vector Vec, we got vector Vec, we got all this stuff going on here. Okay. Let's say vector. Somebody give me a new name. Bob. Okay. All right. Vector Bob equals vector 2. So this is going to call the default copy constructor. Okay. And so if we set vector 2's 20, this is 2. And we got Bob here. Okay, so let's get rid of these other guys just to make it even simpler for you. Okay, so we've got one vector that holds 142s, and then we copy it into Bob. So we've got two copies now, right? We got Vec, we got Bob. And we change Vec's element 20 to be 800. We don't change Bob's. And we're going to print out Vec's element 20 and Bob's element 20. What is it going to print to the screen? Vincent. I like Vincent better. $800 for Vec and 42 for Vincent or Vincent. 800 and 800 from Pool. Pool, why would you think that it's going to be 800 for both of them? Tipton, why do you think it's 800 for both of them? We copied Vincent before we changed. We copied Vincent. It's not a reference. It's a duplicate. Vincent and Vec are at different memory addresses. If I were to see out the address of Vec and Vincent, they're actually pointing at two different variables. And it has copied all of the elements within Vec into Vincent. What do you think? Voss, what do you think? Error? It's going to call the default copy constructor. It'll copy all the values over. All right. Let's compile it. 842. It's 800 and 800. And then we crash. Why? This is why the rule of 3 exists. We copied over, right? The default copy constructor copies all of the member variables over from one to another. So vector has an array pointing at some chunk of memory. It's got a size, it's got a capacity. Now Vincent has a pointer pointing at the same chunk of memory and the same size and the same capacity. What's the problem with vector and Vincent both pointing at the same chunk of memory? If you make a change to one of them, it changes the other one as well. Both of them are actually sharing the same array underneath the hood. So when you change one of them, it changes the other. Worse, when the destructor is called, vector goes out of scope, vec goes out of scope, it deletes the RAM. It deletes the chunk of memory that's been allocated for that array. When Vincent goes out of scope, it also tries deleting it because they're both pointing at the same address. And so it's already dead. And so you try doing what's called a double free. And it kills your program. Okay. They both have their destructors called when they go out of scope. So right here, at the very bottom of main, Vec goes out of scope, and the destructor is called, and Vincent is called also. Both of them called delete on the same chunk of RAM, instant death. Okay? So this is a problem. Every time you have a new and a delete, this is why it's called the rule of 3. Every time you've got a new and you've got a delete in your constructor and destructor, you very, very probably need a copy constructor too. The easiest way of doing it is this. A copy constructor looks like this, by the way. Const vector b. So this is a copy constructor. It is a constructor that takes another of the same class as parameter. This is a special thing called a copy constructor. So when you make a constructor that takes itself as the constructor, it's used to clone one vector to another. And so the easiest way of doing this is to not. Right? Nope, we're not allowing it. Problem solved. Problem solved. I mean, we can't do this anymore, right? But problem solved. Like you just can't duplicate it, right? If you want to duplicate it, do it your own damn self, right? Like, you know, make a new vector, copy all the elements from the one, do your own damn self, right? Or if we wanted to be nice to the people, we could do it. So here we go. So we're copying from, this is like Vec, right? So we're copying from Vec and we're going to Vincent. I'm just going to name it Vec just so I know what's going on here. So we're Vincent and we're copying out of Vec. So rather than copying the pointer, what should we do? Should we allocate new memory because we're a new variable? Should we have the new now? What do you guys think? We're a brand new vector. We should have our own memory. We should not share memory with somebody else. They're both pointing at the same place. So we need to allocate our own memory, right? So we're going to say, how much memory? How many elements are in the other guy? 100 size, right? Okay. So we're going to say our array, r equals new integer vec dot size or capacity. We'll do capacity. Why not? Okay. So if they have 500 elements in their vector, we will make a new chunk of memory that holds 500 elements, and then we are going to have to copy them over. So for integer I equals 0, I is less than vec dot capacity, or we can copy over size capacity. Size, so vec dot size, capacity equals vec dot capacity. Okay. So we just do size, really. Okay. I++. So for every element they have in their vector, we will say our array equals vec.array.I. This is called a deep copy. So before, all it did was copy the pointer over, and I got two guys pointing at the same thing, like the Spider-Man meme, right? Now, instead, we have our own chunk of memory, and we copy over all of the elements from vec into Victor. You guys understand? This is necessary. Anytime you have a new, okay? Anytime you have a new and delete, you need to make one of these things. And then the operator equals is going to be basically exactly the same as this. So the operator equals is going to return a vector void. I'm gonna be lazy. Okay. Operator equals. So this means anytime somebody says like Bob equals Steve, it's not a new variable. It's very close to the copy constructor, but it's not a new variable. It's an existing variable, right? I'm not saying vector Bob. I'm just saying Bob equals Steve. And it's going to invoke the equals operator. Anytime you have an equals or a plus or a minus, it literally just calls a function called operator equals, operator plus, operator minus. It passes in Bob as the left-hand side, and it passes in Steve as the right-hand side. So if we're doing a member function, only the right-hand side's passed in because we are Bob. So we're going to take a const vector Now, the only change here is that we might have memory already allocated. So we need to delete the our current array, and then all the rest of this is going to be the same. Nope. So if we have memory already allocated, like if Bob already has like a gigabyte of RAM, we need to delete that first. And then we're going to just copy over everything from Steve. And now we have fulfilled the rule of 3. This is what you have to do for your next homework assignment. It'll be due on Wednesday. I suggest you guys, if you did not finish SDF2, I highly suggest you get cracking on this now. And then when you get stuck or confused on something, you can ask questions on Monday during lab time. What I want you guys to do right now, though, is I would like for you to write the... are we frozen here? Freeze. Oh. All right. Oh, forget about that then. Nope. Dead. Well, let's just talk about it on Canvas then. So make sure you read this thing over. This is the documentation on the rule of 3 on CPP reference. You should all become intimately familiar with CPP reference now, really. But by the end of the semester, you should be very familiar with this website. It is the best reference site on the C++ language. CPP reference is your friend. So coming into Canvas, let's take a look at the homework assignment here. This is why it's called a Crucible of Souls. It's not called a Crucible of Souls because all the assignments are going to be like, easy, right? Should hurt your brain a little bit. You should have smoke coming out of your ears to do this, right? Okay. Joke's on you, you have no soul. You've been crucibled already. I don't know. Okay, so the new assignment is called Class Playground 2. And Class Playground 2 is a makeup. You won't get full 200% if you do both of them because Class Playground 2 is much easier than SDF2, but it will add together up to a maximum of 150% on your SDF grade. So if you have 4 points right now in SDF2, you do Class Playground, then, which only a few people do, almost, you want 200%, Voss? There's basically nobody in the 5 to 10 range. Like, there's a few people with 1s, a few people with 4s, and then a few 11s, right? And so basically, yeah. You'll get 50% extra credit on top of your 2 points of extra credit. So that's like 170 points. It's fine. It's fine. Okay. So what you have to do for the assignment is you have to implement the rule of 3. So I've created a new class, which you can see on the screen here. Oh, wait, I can't because the server's down. As you can see on the, okay. So you're going to have to do this. So you're going to have to write a destructor, a copy constructor, and an equals operator. It'll be very close to what was just on the screen a second ago. All right. And the reason why I have to do this is because if you don't do the copy constructor, then it copies the pointer. The 2 pointers are pointing at the same chunk of RAM. When they both die in the destructor, it kills the RAM twice. You segfault. So you do that, and then you're going to get a little bit of practice writing a plus equals operator. So like I said, everything in C++, if you say like Bob plus Steve, it calls operator plus. If you have Bob plus equals 5, it calls operator plus equals. Every single operator in the language, almost, can be overridden to make your own function. And so what you're going to do is you're going to make a plus equals function that will just add numbers to stuff. There is one, I guess, tricky part, which is that it is using a 1D array to hold a 2D array. We got a little bit of time. So let me show you guys what that looks like. How do you hold a 1D array as a 2D array in RAM? So if you have an array, 2D arrays are actually a real pain to deal with. They actually are. I've shown you guys how to do like 2D vectors before. They're a pain to deal with because they're not contiguous in memory. And there's always a chance that like one of your rows, you like do a pushback on it. And it's like one of your rows now has like 5 elements, when the other one's at 4. 2D arrays suck. 2D vectors suck. They all suck. 1D, this is using a 1D array as a 2D array. And it sucks also, but you have to have your choice of which one sucks less, I guess. Okay, so how does this work? So what you're going to have is you're going to have like one array. This is what, 4x4. So you're going to have one array, like integer array 16. Okay? But you're going to access it as if you have like rows and columns, right? So you've got your rows over here. You got your columns over here. You got columns 0, 1, 2, 3. You got rows 0, 1, 2, 3. And so you've got a 2D map data, but you're holding it in a 1D array. And so what you do is you do it like this. This is index 0. This is index 1, index 2, index 3, index 4, index 5, 6, 7, 8. Notice any patterns in the numbers. 9, 10, 11, 12, 13, 14, 15. Okay. Every time you go to the right, what happens? R5, and you head to the right, becomes array 6, right? Adds +1. Every time you head left, what happens? -1. Every time you go up, what happens? -1, +1. -4, which is the row size, right? However many columns you have technically, right? Minus, we'll call this columns, right? So minus columns, and every time you go down, you add what? +4 or columns, right? And the reason why it's nice using a 1D array instead of a 2D array is that it's just a pointer, right? You just have your int star named array, and you just pass a pointer to things, and as long as everybody knows what the dimensions are, which is sometimes you have to pass them in separately, then everybody can figure out, okay, well at row 2, column 3, that's index 11. And we can do that math because we've gone down twice, right? And every time you go down, you multiply by 4, and then we traveled right 3 times, and so that is index 11, right? Every time you go down, it's +4. Every time you go right, it's +1. So row 2, column 3, 8 + 3, 11. Okay? Wasn't there a formula? There is a formula. It's a very famous formula, in fact. So it is the row. Sneeze again, maybe. We'll call this I, make it a little simpler. So if you're at I, if you're on row I and column J, then the index is I times calls plus J. That's the index you're at in the 1D array. Because every time you go to the right, one column, you add 1. Every time you go down, I goes up by 1. You add calls 4 in this case. That makes sense? And so there's a little bit of that on the homework assignment as well. Because learning the... thank you for the preemptive blessing. I appreciate that. There is... this comes up a lot, like, honestly. Like, and it's mostly just an artifact of the fact that C++ doesn't have a good 2D data structure. Like, we don't. We're getting one, theoretically, maybe this year. We'll finally have a 2D data structure that doesn't suck. But all the options we have, 2D arrays, 1D array that's a 2D array somehow, like this, and 2D vector, all of them are bad. All of them are bad. There's just no good options for doing 2D data nicely. Okay. 2D vectors are not contiguous in memory is the main issue with them. That slows down performance. It's probably not the reason why you think it's bad, Aaron. Maybe you don't like the verbosity of it or something, but I don't know. But C++ is theoretically getting a matrix class that will allow us to actually do 2D stuff easily. So we'll see. I'm not holding my breath. And that's about it for today. So what I'd like for you guys to do, if the server is back up, we got 16 minutes left, right? Or do we have 5 minutes left? How much time do we got left? Let's see. Recover. I'm gonna purge myself. That's gonna kill the background process. 60 minutes. Okay. Let's see. Recover. There we go. Save. Delete. Okay. So what I'd like for you guys to do is come up with a good pushback function, right? So this is the missing link. And pushback has to do a few things, right? Like if there is room in the vector, take an int value of some sort. If there's room in the vector, right, the value to the end, and increment, what do we call it? Size. If size currently equals capacity, then double capacity, copy the values from the old to the new, and delete the old. Then do number 1. Okay. There's two things that pushback does. So if size is less than capacity, then you're just going to write the value in. The number 2, though, is the kicker, right? So when you run out of room, you have to double the size of the vector, copy all the elements over, deallocate the old element, and then push the thing in at the end. Okay. So I'm going to give you guys 15 minutes to do this. See how much you can get done. The source code for this is going to be copy main.cc public proto-vector.cc. So let's see what you guys can do. Begin.